This lesson's on solving logarithm equations. For logarithm equations, you want to get down to where you have one logarithm on either side. So if I have log base 327 plus log base 3 to 1/3 equals, and I have a logarithm on that side, I want to get so I have one logarithm on either side, and then I can cancel them out. I can use my logarithm rules. This addition rule means my logarithms can multiply. So I have log base 3, and I'm going to combine these two logarithms into one, where it's adding between, so it actually means I can multiply. So it'll be 27 times 1/3 equals log base 3 to the x. Now 27 times 1/3 is just 9, so I'm going to have log base 3 to the 9 equals log base 3 to the x. When I have one logarithm on either side and they're of the same base, I can cancel them out, and I'm just left with 9 equals x. Okay, so get your two logarithms, or whatever logarithms you have, down to just one, and if you have one on either side, you can cancel them out. For my second example, I have log base 2 to the x equals, and I have whole number 1 equals log base 2 to the 10. Now that whole number 1 caused me a little bit of a problem. I need to turn it into a logarithm. So I have log base 2 to the x equals, now this needs to turn into a logarithm of base 2 as well. Now that 1 would have been the exponent. So it's 2 to the exponent of 1. Okay, so log base 2, 2 to the 1 is what that whole number 1 would have been. Plus log base 2 to the 10. Now I have two logarithms again that are adding. Adding means I can multiply using my logarithm rules. So it's log base 2, 2 times 10, okay, which is log base 2 of the 20. And I log base 2 to the x on the other side. Now I have two logarithms, okay, sorry, one logarithm on either side. I can simply cancel them out, and I'm left with x equaling 20. Okay, so again, get your two logarithms, turn them into one logarithm, so you have one logarithm on either side, and then you can cancel them out. If you have a whole number, turn it into a logarithm before you even get started. For my last example, again, I want to get, so I have one logarithm on this side, and then I can cancel out my logarithms. So adding again means multiplying. So I'm going to have log, and it's of base 10, so it's going to be log x times x plus 1 equals log 30. And we use distributive property here to have log be x squared plus x equals log 30. Now I have one logarithm on either side. I can cancel it out, and I'm left with x squared plus x equals 30. Take my 30 over to the other side, make it equal to 0. This is a quadratic, in which case I can factor it, so it's going to go x plus 6, x minus 5 equals 0, and x is going to equal -6, and x is going to equal +5. Now I have to look back. Those are my two possible x values. Look back and make sure they're both possible. If I had -6 and I was to put it in where the x is in my logarithm, I would have log -6. That is not possible. I cannot take the logarithm of a negative number. So that is not possible. So it leaves me an answer of just x equals 5. Again, I got two logarithms, combined them into one, and then I was able to cancel out the logarithm on either side. This is a short note on solving logarithm equations, brought to you by Energized Math. Please visit energizedmath.com to download this note. Thank you very much.